Hi everybody, this is a video for lesson 1.3 in phase change. I know a couple of you guys are going to be gone today, and I told you to watch the summary. So I'm going to try and make this as quick as I can, but I want to make sure that I've talked to you guys about what we did today and that you understand, so when you come back, you're ready to just jump right back in. So in the previous lesson, we discussed the appearance of substances at the macro scale. So if you remember, we talked about solid, liquid, gases, what they look like, and then I had you guys read that article about Titan Fact Sheet. So knowing that there are differences between phases, knowing that there are macro scale or visual differences between the phases is not enough to help us solve the mystery of the methane lake on Titan. We also need to understand more about what makes the phases different and what happens during freezing and evaporation. And when I say what happens, I mean what happens with the molecules. What's going on the smaller scale that we can't see that is causing a solid to be rigid and hold its shape, and a liquid to flow and take the shape of a container, and a gas to be to fill the container and to not be visible or not really have a shape. So we're talking about observing substances on two scales. I've already introduced the term macro scale. That means substances that can be observed with the human eye, with the naked eye, with no assistance from any kind of a tools. And then we have a scale called the molecular scale. And if you look at the word molecular, it's an adjective describing molecules. So molecules that are too small to be seen with the human eye are what makes up matter. And so they behave in a certain way, and it's that behavior that we need to look at. So in this little picture, you see a picture of a water molecule. A molecule is when you've got more than one atom that's bonded together to make a molecule. So vocab word scale, that's the relative size of things. So macro scale is big, things that we can see with the naked eye. Molecular scale is small, super small. In fact, so small that we cannot see it at all, and we have to use models to kind of interpret what we think is going on. We also have the word molecule. This is a group of atoms joined together in a particular way. And then third, we've got thermal energy. Thermal energy is a measure of kinetic energy. So remember, kinetic energy, we're going to shorten to capital K, capital E. So if you remember, way back at the beginning of the year, I had that station for you to measure the temperature, and we had thermometers, and you guys did a little bit of reading, and you remember that you read, hopefully you remember, that you read that thermal energy is a measure of kinetic energy, which is the movement of molecules. So however fast or slow molecules are moving, that measurement is called thermal energy. And if you remember in class, I had the kids put their hands together. We did this before last week, I think we did this, where you put your hands together and you rub them together really slow. That's very slow kinetic energy. And so the measure of that kinetic energy is that your hands aren't very hot. But when you speed up your hands, that increases the kinetic energy, and therefore the measure of that kinetic energy would increase, and thermal energy increases, and it increases the heat, and we get temperature from that. So I talked to a couple of you guys about this. If you know what we did today, go ahead and fast forward this part of the video. If you were gone, one of the activities that we did, I'm just going to have to ask you guys to use your imagination. I poured some boiling water in the styrofoam cup, and then they placed that plastic cup on top of it. And we're observing a phase change because the water is liquid water in the styrofoam cup. But you can imagine that what they saw on the inside of the plastic cup over time, and it wasn't that long, but they started to see beating of the water molecules. So what had been gas was being turned into liquid. And of course, that is, it's opposite. It's evaporation, and it starts with a C, you guys. I'm 53 years old. What the heck? All I can think of is constellation. What is wrong with me? You guys know the word I'm trying to say. I'm old. Oh my gosh, I just had a brain fart and I can't think of it. Anyway, it's the phase change where gas becomes a liquid. I cannot believe I can't remember I can't say the word. That's really frustrating to me. Whatever. So that what we see is the macro scale. But what we can't see is on the molecular scale. We're trying to figure out what is going on with those molecules between a liquid and the gas that's causing that gas molecule to turn into a liquid molecule, or not molecule, but the gas, molecules, yeah, to change their phase to a liquid molecule. Okay, I'm gonna go through there. So what changes did we observe? We observed condensation. My word. We observed the gas condensing on the inside of the cup to a liquid. That's what we saw. And the evidence that we saw water in the form of gas is that we did see the steam. Now remember, steam, the reason why we can see that is because it's sort of halfway between a liquid and a gas. That's why we can see the steam. But it was moving in a way, then it collected on the cup, cooled off, and then that's when condensation occurred. Okay. So then that helps us investigate whether the lake on Titan evaporated or froze. So what happens to the molecules of a substance when it changes phase? You have a copy of this PDF in Schoology. Go ahead and copy that to GoodNotes and then come back and watch the video. I want you to just kind of think about what you think happens to substances at a molecular scale and draw a model that shows your predictions. So you've got a box there that goes a solid, a liquid, and a gas. We're going to use, I'm telling all the kids in the class, I want you to use a circle, like a small circle that represents a molecule. And so talk to me, let's put like 5 molecules in the solid, 5 molecules in liquid, and 5 molecules in gas. And show me what you think those molecules are doing when something is a solid. How do they move? Where are they in relation to each other? In a solid, a liquid, and a gas. Later on, we're going to have a chance to revise, so don't worry if you're right or wrong. I just want you to get your initial ideas out. Pause this video, do that, and then hang on to it in GoodNotes. Okay, so the next thing I want you to do is go into the simulation. The sim is a pretty cool phase change simulation that we're going to use to help us learn more about how substances experience phase change on a molecular scale. So you're going to notice that the molecules there are represented with small circles, which is why I had you use small little circles to represent your molecules. These little purple molecules, you'll see that actually what I'd like you to do, just mess around. What can you do? What are some things that you notice? And I'm going to have you stop there. When you come back, you and I will work a little bit more on understanding what these substances are over here in the white box. You've got substance A, B, C, and D. One is a solid, one is a liquid, one is a gas. I would love for you to see if you could determine which one is which. But for right now, just play along with that sim. Just mess around with it, see what you can find. And then when you come back on Monday, we'll make sure that you're caught up and ready to go. All right, take care. Talk to you later.